The objective of this video is to identify even and odd functions. Even and odd functions have to do with symmetry about the graph and how the points with positive x values relate to the points with negative x values. Specifically, we define a graph to be even if it is symmetric with respect to the y-axis. And if you remember what symmetric with respect to the y-axis means, I have an example down here. It means that you can basically fold the graph along the y-axis and get the graph to lay upon itself. And let me kind of illustrate that here. If I actually flip this graph from left to right, which would be flipping it across the y-axis, you see that the graph is unchanged. And that's what it means for it to be even or symmetric with respect to the y-axis. So how do the points on those graphs relate then to each other? We say that if the point AB is on the graph, then the opposite of A, B, is also on the graph. Here it's designated with x and y. If xy is on the graph, then negative xy is on the graph. So what that is saying is that the opposite x values have the same or equal y values. So opposite x have equal y. So if opposite x have equal y, then the graph is even. A graph is odd if it is symmetric with respect to the origin. Now, to be symmetric with respect to the origin basically means that you have to fold the graph along the x-axis and y-axis, and then if the graph lies up on top of itself, then it is odd. So let me illustrate that with this particular graph I have here. So if I'm thinking about, let me back up just a minute. We fold it along the y and the x. So let me flip it across the y, and now let me flip it across the x. You see then that the graph is unchanged. So this is called an odd function. How do the points on the graph relate to each other? Well, the points AB and the opposite of A, opposite of B are on the graph, right? If this was my point XY, when I flipped it twice, it was the point negative x, negative y. Both the x and the y are opposite. So the way we define this, we say if opposite x have opposite y, then the graph is odd. Okay? So if opposite x have equal y, then the graph is even. If opposite x have opposite y, then the graph is odd. Now, how can we determine it algebraically? If we're given an algebraic function, to determine if a graph is even or odd, what we're going to do is replace the x with the opposite of x in the function and compare it to the original function. If it is equal to the original function, then the function is even. If it is opposite of the original function, then the function is odd. So, if the replacement with negative x gives either the same function as we started with, it's even. If it gives the opposite function, then the function is odd. If it gives neither of those, then it's neither even nor odd. Now, let me back up and show you one last thing. I didn't say this earlier, but this is the way we state that mathematically. We say if f of negative x is equal to f of x, then the function is even. So that's saying the opposite of x have the same output value. Here we're saying that f of negative x is equal to the opposite of f of x. So that's saying that opposite x values have opposite y values. So let me show you some examples of this. And I've selected these from the textbook problems. Let's look at number 59 to determine whether it is even or odd. So to determine if this is even or odd, I've got to replace the t, in this case, with a negative t. So I've got to find out what is f of negative t. So remember, all we're doing is substituting in place of the t, negative t. Now remember, when we square a negative t, we get just a t squared. 2 times negative t would be minus 2t minus 3. So now we want to compare that to our original function. The original function was t squared plus 2t minus 3. Notice that is not the original function. The opposite of the original would have been a negative t squared minus 2t plus 3, which it is not that either. So this one is neither even nor odd. Okay. Now what about number 61? If we find g of negative x, in this case we would have negative x cubed minus 5 times negative x. Cubing a negative gives us a negative result. Negative 5 times negative x would be plus 5x. So notice this is definitely not the same function, because that was a positive sign and then a negative. But notice it is actually the opposite of that original function. So this is indeed the opposite of g of x. So this function would be odd. And if you're very observant, you can tell me what would define that. Do you notice the powers on our x and our original function are 3 and 1? They're both odd, and so it turns out if you have all odd powers, the function will be odd. And notice in number 59 we had an even and an odd and an even. 3 is really times x to the 0, but when you have a combination of even and odd powers, you're going to get neither even nor odd. Now let's look at number 63 and then we'll finish this out. 63 is f of x is x times the square root of 1 minus x squared. So if we plug in negative x in place of x, we would get negative x times the square root of 1 minus a negative x squared. And so here that's negative x times the square root of 1 minus. When we square a negative x, we get just x squared. So how does that compare to the original function? Well, it is actually the opposite of the original function. And you're going to say, hey, you just told me if you had a combination of even and odd functions or odd powers and it doesn't work. Well, that's because this is not a polynomial function. It's inside a square root. So what I said earlier only holds when you have polynomials, so just addition and subtraction of powers and constants. Okay, so this would be odd. Now, let me finish this up with one other type of exercise. It says to think about the coordinates of a second point on the graph if you're given this one particular point, if you know the function is either even or odd. So let's look at number 67, for instance. If I know the function is even, then what that would tell me another point on the graph would be is this. We know opposite x would have equal y values. So if the function is even, then another point on the graph would change my sign to the opposite of x to be positive 3/2, but I'd have equal y, so that would be 4. If that was odd, then the opposite of x, so the opposite of x is 3/2, would have the opposite y value, which would be negative 4. Okay. What about number 70? So if it's even, I'd have opposite of x, which would be negative 5, and the same y would be negative 1. If it was odd, opposite of x would be negative 5, and opposite of y, which would be 1. And in the next objective, I'll show you how you can use your calculator to actually verify if you have an even or odd function. Okay? Thanks.